Hey there, here's the lesson, L2, calculus, differential calculus that is, for this one, to do with more complex curves. So if you learn how to differentiate kind of basic things, for example, you don't need to write this down, you've learned to differentiate, okay, if y equals 3x to the 4 plus 4 plus 7x minus 2, then dy dx, this is just a recap, you do 4 times 3 gives you 12. So you times the exponent by the coefficient, and then you write x, and then the exponent goes down by 1. So x cubed. X terms just become the coefficient. So it's a cube plus 7, and then constant terms don't appear in the derivative. So you don't need to write that. That's just a recap on basic calculus from last lesson. We're doing just slightly trickier ones. So like, for example, what do you do? I'm just checking we're recording. Yeah, we are. Hang on. Here we are. Just what happens when you've got x in the denominator, for example. What happens when you've kind of got x in the numerators and denominators? Like, what do you do then? Just a little bit more. It quite requires using your exponent laws a little bit more. So differentiating can be a little more tricky when you have x terms in the denominator, like these ones, of a function. Below are 2 examples which we'll work out step by step. So notice example A I kind of do down here in blue. Example B I do down here. I'll go through it step by step. So for example, the instruction would be find the gradient function of the following. Or it could be for this one find dy dx, or for this one find f dash x. So notice that this one's got x's in the denominator, and it's just got a regular x here. And it's this one's got x's in the denominator and numerator. So the first step before you even begin to find the gradient function is to flatten the function. Before we do find the derivative, we shouldn't have any x's in our denominators. We've got to get them out of the denominators. So you're going to use the negative exponent laws to get these ones out of the denominators, and you'll do some cancelling down to get this one out of the denominator. Oh, great. Okay. Alrighty, so the first step before you even sort of done that, to do this you need to break up the numerator if it's not already broken up. Remember, you cannot break up the denominator though, so you can break up a numerator, like you can break this into 4x to the 4 over x plus 5x squared over x minus 3x over x minus 2 over x. You can break up a numerator, you're just not allowed to break up a denominator. Remember, like killing a kitten. So you can't break up a denominator. A is already broken up, so that's fine. But B needs to have its numerator broken up into 4 separate parts first. So what I did was here in this step here, I just repeated the question because the thing's already broken up into 3 separate terms. This one I'm going to break into 3 separate terms because there's only one thing in the denominator, so we can break up the numerator. 4x to the 4 over x plus 5x squared over x, take away 3x over x, take away 2 over x. So be careful when you break it up, don't mess up that kind of thing. So I'll go through the blue one first, and then we're going to kind of like, I'll go through the blue one first, and then I'll go back and go through the green one. So now, for this one, you do some cancelling down in this one, but for this one you don't do cancelling down. The reason why we cancel down in this one, by the way, here I am just jumping over to the next one, just so the instruction's not confusing. See, there's nothing I can cancel down here. There's a 3 and there's an x squared. I can't cancel down anything from the top and bottom. Can't simplify this fraction. X, just x. Whereas 4x to the 4 over x to the 4 over x to the 1 will cancel down. So that'll give you, if you kind of cancel down here and here, that'll give you, I just want to make it so it's thinner, so it's not going to be so blobby. X to the 4 over x, that'll cancel down to give you 4x cubed. And then this x squared over x will cancel down to give you just x, so plus 5x. This x over x cancel down completely, so you just end up with minus 3. And this one, you can't cancel anything down, so just rewrite it 2 over x, which is that thing there. So that one we didn't need to cancel this one down at all because there's nothing you can cancel down here. But here I could cancel down a bunch of x's to get a more simplified looking thing. So now for this blue one, I still have the same question that we had to begin with. Haven't done anything to this blue one yet. So now what we need to do is we need to get the x's out of the denominators. So before you find a derivative, you can't have any x's in any denominators. So this one's got an x only in that denominator. So what we do is we use the negative exponent law. So now I call it flattening the function. It's basically just getting x's out of the denominators. To do this, bring any x's in the denominator up into the numerator just by simply using the negative exponent law. So remember 1 over x, that's like 1 over x to the 1. So you might want to put an invisible 1 there. 1 over x to the 1. What you do is you bring the x up and you make the exponent negative. Or like, for example, 3 over x squared is the same thing as 3x to the minus 2. So see, you bring the x up and you make the exponent negative. Bring the x up and make the exponent negative. So now we're going to do that to this little one. Oh, what a coincidence, I've got the same one here. So 3 over x to the 2, just bring it up and make it 3x to the negative 2. So we're not differentiating here, that's why I'm still calling it y equals, and then we're going to differentiate. So that's 1, because that's like saying 3 times x to the negative 2. 1 times x to the negative 3 would be x to the negative 3. Bring that one up, make the exponent positive. And that one's already got a positive exponent, and there's no denominator with x's in it. We're fine. That's just x, or x over 1. And then I can do the calculus on this one. So just do regular calculus. So this one's in form of y, so dy dx equals negative 2 times 3 is negative 6x, and subtract 1 from negative 2, you get negative 3. And then negative 3 times 1 is negative 3, is a new coefficient, x, and then subtract 1 from the exponent, you get negative 4. And that's just like an invisible 1 there, isn't it? Like 1x. So 1x just becomes 1. Remember, x terms just become the coefficient. Beautiful. Okay, so if they don't say you need to write your answer with positive indices, just leave your answer like that. So that would be the version of your answer, just there. But sometimes a question might say your answer must be written with no negative indices, or they'll say your answer must be written with positive indices. In Australia, we have to automatically turn everything into positive indices. But here, you only do it if you're asked to. So to make them positive exponents, just bring them back down into the denominator at the end, because you've done your differentiating, that's all done. It's fine to bring it back down into the denominator. So negative 6 stays on the top. X to the negative 3, just bring down to the bottom and make it x cubed. Minus 3, so I just made it minus 3 over all, and x to the positive 4 on the bottom, and then minus 1. So that would be the answer if you were asked to leave it with positive indices, or sometimes they say no negative indices. So now I'm going to go through and finish off this green one. So this green one here, we were up to here. So we had 4x cubed plus 5x, formatting looks weird, minus 3 minus 2 over x. So remember, like before, we had to get x's out of the denominator before we differentiate, before we find f dash x. So that's like an x to the 1 here is, oh, got it in yellow still. That's like an x to the 1 there. So bring that x up and it would become, so it's minus 2, x to the negative 1. And now we differentiate this. So this is f of x, and then so therefore the derivative will be f dash x. So here's the original function, its derivative will be, start with 4 times 3 is 12. X, don't forget to write the x, sometimes people just write 12 squared. So 12x, subtract 1, you get an exponent of 2. So this is just an x term, so it just becomes plus 5. Makes sense because 1, if you had an invisible 1 here, 1 times 5 makes 5, and then subtract 1 gives you x to the 0, and x to the 0 is 1, and 5 times 1 is 5. So hence that's why x terms just become the coefficient. Minus 3, that's a constant term. So constant terms don't appear in the derivative at all. And the reason why, as I said, like negative 3, that's like think of it as like negative 3x to the 0. 0 times negative 3 makes 0, x to the negative 1. And 0 times anything makes it just 0. So that's why the constant terms don't appear in the derivative. And here, negative 1 times negative 2 makes positive 2 here. Don't forget to write the x. And negative 1, take away 1 is negative 2. So here's the derivative of this one. So and if they don't ask for positive indices or no negative indices, that would be fine as an answer. If they do ask for positive indices, see that's a positive indice, doesn't have an index, so no problem. And then, I'm going to stop that happening. And then negative, I'll just pause and I'm actually just going to close my emails. Okay, email closed. Right, so so we've got a positive exponent here. Here there's no exponent, so no problem. We just need to make this one positive if they need no negative indices. So just bring the x squared down to the bottom, make it plus overall, 2 on the top, coefficient on the top, and the x, bring it down to the bottom and make the exponent positive. And then you would have that answer. So both of these are the same answer. Both of those are the same answer. Both of those are the same answer. Yay! Now let's do a page of some examples. Yay! Feel free, if you want to try these yourself first and then just check with mine as you go, you're welcome to. So differentiate the following. Don't forget to flatten it first. Got to flatten it first, get the x's out of the denominators first before you find the derivative. So that's important. So we're dealing with the original function first just by getting x's out of the denominators, and then we're differentiating. So here we've got 7x, a bit fuzzy, sorry, 7x minus 4 over x to the 1 plus 3 over x cubed. So 7x has still already got a positive exponent of 1. So that's an exponent of 1, so bring it up into the numerator and make it 4x to the negative 1, make the exponent positive, negative, sorry. And then it's still a minus, plus 3, bring the x up and make the exponent negative, 3x to the negative 3. And then once you've got the x's out of the denominator, then you're fine to differentiate. So remember that's an x term, so think of it as 7x to the 1, 1 times 7 is 7, x to the 0 is 1, so 7 times 1 is just 7. So x terms just become the coefficient. Negative 1 times, because this is f of x, the original function, here's f dash x, the gradient function. Negative 1 times negative 4 is positive 4. Don't forget to write the x. Subtract 1 from negative 1, you get negative 2. And plus 3x to the negative 3. So my negative 3 times 3 is negative 9 is the new coefficient. Don't forget to write the x. Negative 3 take away 1 is not negative 2. Negative 3 take away 1 is negative 4. The question didn't ask for positive indices, did it? So to be honest, that answer's okay, but practice turning it into positive indices because sometimes they ask you to. So both are fine for here, but we'll just practice this. So 7 just stays 7. 4x to the negative 2, just bring the x down with its exponent, make it its exponent positive. Minus 9 on the top, bring the x down and make its exponent positive. And that would be the answer with positive indices. And this little one here, so we've got x squared plus 4x minus 5 over x. Let's break up the numerator first. So it looks a bit of a mess there, sorry, so I'm going to break up the numerator up here instead to start with, so you can see just straight up we've got x squared over x plus 4x over x minus 5 over x, and then we cancel them down, so you'll see the cancelling downs happened here. Actually, do you know what I'll do is I can write it in here. Should have thought of that. Make it look a bit, I'll colour code it here so it's a bit clearer. X squared over x plus 4x over x. See, I'm just writing the original in green. Probably still going to look horrible. That's an x underneath. Minus 5 over x. And then I'll try to do some cancelling down in yellow. So I can cancel down that. And that's just going to give me x. Cancel down that one and that one. That one's going to give me just 4, because x squared over x just becomes x. 4x over x becomes just 1, so that's 4. And 5 over x, well, I went straight to flattening it. This one doesn't cancel down, so I just went straight to bringing that one up to here. So it's a minus. Just be aware it's a minus, not an equals to sign, in case that's confusing. So that's x to the 1, so bring it up and make it minus 5x to the negative 1, because you make the exponent negative. So that's still the original function. Don't forget it's still the original function. And then we do the calculus. We find f dash x, which is the derivative. Same with that one, that's just f of x. So this one is f dash x, the derivative function. So that's 1x. So 1x just becomes 1. That's a constant term. Remember, constant terms don't appear in the derivative because that's like 4x to the 0. And 0 times 4 just makes the whole thing 0, so that's why it doesn't appear here. Negative 1 times negative 5 is positive 5, and then don't forget to write the x. And negative 1 take away 1 is negative 2. So that would do fine if you were not asked for positive indices. If you're asked for positive indices, then you have to bring the x to the bottom, make it plus 5 over x squared. if you wanted positive indices. Yay, yay. Now let's do three more examples. Yay. All right, so 3 more examples. Let's leave them up so you can see them all. I'll do these ones in green again so you can see them a bit better. So to start with, it's you break up the numerator. So 2x over x squared. So that's 2x over x squared minus 3 over x squared. 3 over x squared. Then do some cancelling down if you can. X over x squared. The x and the x, so it simplifies so you end up with just an x here. So these two x's cancel out, but you still will have an x on here. So if you want to write that here, it's maybe not that clear. So equals 2 over x, there you go, minus 3x over x squared. Because there's no cancelling down you can do in this one. 3 over x squared just stays 3 over x squared. But the 2x over x squared, you can cancel an x from the top and the bottom. So that just leaves you with 2 over x instead of 2x over x squared. And then that's a 1, invisible 1 here, so bring it up and you'll get 2x to the negative 1. So remember, this is still the original function. So this is still the original function, we're just flattening it. We're getting the x's out of the denominator. Sometimes it's so much work doing this, sometimes that people think they've found the derivative already. But here you're just expressing the original function and then you find the derivative down here. So it becomes 2x to the minus 1, take away, bring the x squared up here and make the exponent negative, minus 3x to the minus 2. Now you differentiate what you have here. We've flattened the function, we've gotten the x's out of the denominators, and now we find the derivative, the f dash x. So negative 1 times 2 is negative 2. Don't forget to write the x. Negative 1 take away 1 is negative 2, in case that's not clear. Negative 2. Negative 2x to the negative 2. Negative 2 times negative 3 is positive 6x, and negative 2 take away 1 is negative 3. So here's the answer. It doesn't say again. It doesn't say to do the answer with positive indices or no negative indices, so that's okay. If they did want negative indices, you would have negative 2 on the top over x squared plus 6 on the top over x cubed, and that would be it with positive indices. And now we've got one that we can break up because we've got fraction. These are all breaking up the numerator ones. So let's do that on here. X cubed over x, so that's the first thing to do. X cubed over x plus 5 over x. So first step, break up the numerator. You can break up numerators, but you can't break up denominators. Then we can cancel down a little bit, if it's possible. X cubed over x just becomes x squared. And 5 over x just stays 5 over x, but maybe you want to bring that up here. I'm being lazy and I'm doing 2 steps at once. So that becomes x squared plus 5 over x, and then 5 over x is the same as, because that's an invisible 1, bring that one up, 5x to the minus 1. Don't forget these are still the original function. And now we've gotten the x's out of the denominator, we're going to differentiate and find the derivative of the original function. So that's an invisible 1 there, so 2 times 1 is 2x, and then subtract 1, 2x to the 1, which is the same as 2x. Negative 1 times 5 is take away 5x. Negative 1 take away 1 is negative 2. So as I said, if it doesn't say express it with positive indices, then you can leave it like that. If it wants positive indices only, 2x, that's already got a positive exponent of 1. Minus 5, bring the x down and make its exponent positive, 5 over x squared. Yay. And then we have this one here, x cubed over x. So first of all, break up the numerator. X cubed over x plus x over x minus 3 over x. And let's see, we can do a little bit of cancelling down, so let's do that. X cubed over x cancels down to give us x squared. X over x, anything divided by itself is just 1, so plus 1. And minus 3 over x, we can't cancel down. But maybe these are already flattened, so I'll flatten this one at the same time. So 3x to the minus 1, take away 3x to the minus 1. So, and again, that was still the original function, so I'm color coding that to point out it's the original function still. Derivative, I'm expressing as f dash x here in a different color, so you realize we're now into differentiating. 2 times 1 is 2x to the power of 1, so 2x. Remember, constant terms don't appear in the derivatives. And then negative 1 times negative 3 is positive 3x. Subtract 1 from here, you get negative 2. So here is the answer with negative exponents. Here's the answer with positive exponents. So that one's already got a positive exponent of 1. Bring the x down and make its exponent positive. And that's the end of the lesson. Well done.